Hey space fans, welcome back to our channel where we uncover the mysteries of the cosmos. Today, we've got groundbreaking news that will shake your understanding of the universe. Get ready to dive into the incredible discovery of the gravitational wave background. Let's get started. First detected in 2016, the gravitational wave background has fascinated astronomers and physicists alike. Recently, a second dataset was released by the European Pulsar timing array, confirming the existence of this cosmic phenomenon. And now, with the addition of data from the Indian Pulsar timing array, we have even more compelling evidence. Gravitational waves are ripples in spacetime caused by some of the most violent processes in the universe, such as the merging of black holes or the collision of neutron stars. Predicted by Einstein in 1916 as part of his general theory of relativity, these waves travel through space, largely unhindered by anything in their path. The first direct detection of gravitational waves was achieved in September 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO. This groundbreaking discovery came from the merger of two black holes 1.3 billion light-years away. LIGO, with its twin detectors in Louisiana and Washington, uses giant L-shaped arms to measure tiny fluctuations caused by passing gravitational waves. The gravitational wave background is essentially a random distribution of these waves permeating the universe. The European Pulsar timing array detected this background by observing slight variations in the timing of pulsars, rapidly rotating neutron stars that emit beams of radiation. The theory suggests we are seeing the combined signals from supermassive black hole mergers across the cosmos. Pulsar timing arrays, PTAs, function as galaxy-sized detectors. By monitoring the arrival times of pulses from a network of galactic pulsars, scientists can detect the subtle effects of gravitational waves. These arrays include the European PTA, the Indian PTA, the North American Nanohertz Observatory for Gravitational Waves, and the Parkes PTA. A team led by J. Antoniadis from the Greek Astrophysics Institute has been analyzing the latest data from these PTAs. By combining high-quality data from 4 different sets, they've found more evidence supporting the existence of the gravitational wave background. This discovery is akin to the cosmic microwave background radiation, offering us a new way to explore the universe. With continued observations and more data from pulsar timing arrays, the gravitational wave background will become even clearer. This new method of exploring the universe will allow us to unlock secrets about the formation and evolution of galaxies and the nature of space-time itself. This is just the beginning of an exciting new chapter in astronomy. By harnessing the power of gravitational waves, we're not just looking at the universe, we're listening to it. Stay tuned as we continue to bring you the latest discoveries from the frontier of space research. Thanks for watching, Space Explorers. Don't forget to like, subscribe, and hit the bell icon so you never miss an update. Keep looking up and keep wondering. Remember, the universe is vast and full of mysteries. Let's explore it together, one discovery at a time. See you in the next video.